been happening to me. These search screens just all of a sudden stop for me for whatever reason. And again. Happening again. Well, might have some trouble here. One more time, folks. Not have some problems with the shared screen here. Okay, the quiz. Uh-oh, happened again. This might be one of those days, folks. Well, I'm going to try it again, and I have to think of options in the meantime. I might be forced to close and then open up again. That's worked in the past. Seems to be holding just for a few seconds, which is not what I want, obviously. Anyway, this is the answer to the quiz. ln absolute value of x minus x cubed plus 3 to the x. Number 2, 10 to the x over ln 10, 8 radical x. Don't leave your answer as x to the 1/2 power. This would be a square root. Ln equals absolute value. 4 inverse sine of x plus 3 sine 2x plus the constant. Okay. I know some of you just joined. Send me an email again about that. So let's see how long this lasts. Keep going, see what happens. So time-wise, we're fine. I mean, frankly, even if I lost the entire database, which I'm not aiming to do, but we're still okay time-wise. Okay, so I'll continue with 5.2. I don't really even have to start 5.3 until Wednesday even. I got all these extra days. But let me go ahead and say, so I'm aiming for the last test to be Thursday the 10th. It doesn't mean I'll give it back to you the next day, though. I want to leave Friday the 11th for a review day. And the review should more be like review of previous exams. Okay, so if you have a question about the previous exam, and that's how you study for the final, honestly say, how do I study for the final exam? Look over the previous exams. And cheat sheet-wise, if you have all your previous cheat sheets, just bring them all together. You don't have to reinvent the wheel. You got all your formulas for first test, and the second test, and the third test, and the fourth test. You might as well just keep them. And then you have the fifth one, of course, which we're making now. And just use the same thing. Now, if you say, well, I already threw away my previous cheat sheets, well, you have to make them up again, I guess, for the final. Again, our final exam is Wednesday, the 16th. We don't meet Monday, the 14th. We don't meet Tuesday, the 15th. Final is Wednesday, the 16th. And please notice the time is 11:10 to 1:40. Okay, so for now, I'll aim for this day. Yeah, it doesn't mean I'll give it back to you to test on Friday. I don't know if I can finish it that fast, but I'll try to get it back to you that weekend. But I want to reserve Friday for a Q&A session. And then you still have the weekend. Hopefully, I'll finish the test by the weekend. I mean, I normally finish the test by the weekend, and I'll try to post a video about that so you still have time to study for the final in terms of the last test. So even now, it would not be a bad time to start reviewing for the final exam. I mean, you already have 4 of the 5 tests. So go back and review those exams as you start doing new stuff. Okay. It's a short week. I will give you a quiz on Wednesday. Okay. No school for Thanksgiving Thursday and Friday. So I'll give you the quiz Wednesday as normal. You won't have to turn it in until Monday, just before class at 12:10. You know, again, if you want to play the game, just get the quiz over with. You know, as soon as I give it to you, finish it on Wednesday, then you can enjoy the rest of the long 4-day weekend. You know, that's fine. But if you can turn it in on Monday, or you want to work on it Thanksgiving Day or Black Friday, and any of the other days, you can certainly do that also, as long as I get it by Monday the 30th. Okay. All right, so continuing on with 5.2 now. All right. The properties of the definite integral on page 385. Okay, right now, again, the definite integral is just a theoretical construct. So, for instance, the definite integral from 0 to 3 of the function represents this area under the curve counted as a positive, this area bounded by the curve on the x-axis counted as a negative. It's the true area. Okay, right now, we only know how to approximate negative 6.75 or whatever. Okay, so here's some properties of the definite integral. You can put these on your cheat sheet if you would. Page 385. Integral from b to a of f of x dx is equal to the opposite of the integral from a to b of f of x dx. Okay? So normally we go from left to right. We go from 0 to 3. So what about if I go from 3 to 0? That's going to be the opposite of the value. Okay, there's actually good reasons for that, but we're going to need that for section 5.3. But the main thing is when you're doing your delta x, when you go base times height, your delta x's are going to be negative. If I travel from 3 to 0, right, okay, then we're going to say delta x is a negative quantity, negative, negative. So theoretically, the computations are all the same, except that's going to all come out to be negative. So we're going to say the integral from b to a is the opposite of the integral from a to b. You might say, when will we ever do that? Well, we're going to see that quite a bit in the next section, chapter 5.3, especially when it's possible that you don't even know which one is the larger. You don't know if this is bigger than that one. So the integral from a to b is the opposite of the integral from b to a. This one I think should be somewhat obvious. The integral from a to a. So we're talking about an area under a curve, right? So if you start at a and you end up at a, it means you didn't move anywhere. So the integral should be 0. Makes sense. Right? So the integral from a to a of any function is always 0. These properties we don't emphasize that much. Okay, I mean we'll see some of this, but this is the big one here. I think it's number 3. Okay, if you have the integral of a constant times a function, it's the constant times the integral of the function, right? Just like it was for derivatives. Okay. 2 and 4 you sort of already know. Integral of a sum is a sum of the integrals. Integral of a difference is a difference in the integrals. That works for definite integrals. That works for indefinite integrals. Okay. Number 1, do you have to memorize it? Not really. Okay. I mean, you'll learn very quickly how to do something like that. Okay. So I'll just mention that this is a constant integral of c dx. Okay. We're talking about base times height. So base times height would just be c times the length of the interval, which is b minus a. Okay. Go illustrate with something like this quickly. F of x equals a constant. Okay. So the integral from a to b of c dx. We're talking about the area under the curve. Well, in this particular case, we can find it exactly because it's a rectangle. Base times height. So how far is it from a to b? B minus a, bigger minus smaller. That height is c. So what's base times height? C times b minus a. That's the reason why property 1 works. And again, I don't really think you have to memorize it because you'll learn how to do it better than the way I'm showing you. Okay. But this is geometrically what's going on. Area under the quote-unquote curve. This isn't even a curve. It's just a straight horizontal line. Okay. So I can find its area. Base times height, c times b minus a. So that's what that was about. Okay. The next property I want to show you on page 387. It's also fairly intuitive, I think. Figure 15. It's on page 387, but I'm not showing you the rule yet. I'd rather you just kind of figure it out. Suppose I take the integral from a to c. Integral from a to c. that is this true value, which right now it's only a theoretical construct. We don't know what it is exactly, but I'll trace it out. There, down, and over. Right, one more time. Up, there, down, and there. That's the integral from A to C. Then the integral from C to B is this. Up, over, down, back. One more time. Up, over, down, back. Okay, that's the integral from C to B. So suppose I want the integral from A to B, which I will trace. Up, all the way here, down, and back. One more time. Up, all the way there, down, and back. I could write it as the sum of the integral from A to C plus the integral from C to B. And there it is. Makes perfectly good sense. The integral from A to C plus the integral from C to B, well, it's going to be the same thing as if I just went straight from A to B in the first place. Right? So the integral from A to C plus the integral from C to B is equal to the integral from A to B. Looks very obvious. Okay. Okay, these comparison properties, you can look at it or not. We're not going to emphasize it too much. They're true, but in my opinion, you can survive without them. So I would say don't even put them on the cheat sheet. You can live without them. Okay, so now let's go back to do some more problems from the homework. Okay. So let's look at number 3. F of x is x squared minus 4. X is between 0 and 3. Find the Riemann sum. Okay, don't worry about this Riemann sum. You're just doing base times height, base times height, base times height, base. Those are Riemann sums. N is 6, and it takes 7 points to be midpoints. Illustrate with a diagram. Okay, so you're going from 0 to 3. What's the distance from 0 to 3? 3. Chop it up into 6 pieces. What's my delta x? The length of each subinterval. 0 to 3, 6 pieces, 1/2. Delta x is 1/2. Okay. So, the picture now. .2 number 3. Okay, f of x is x squared minus 4 between 0 and 3. And at 6, they want us to pick the midpoints. Okay, so we split it into 6 subintervals. Okay, where delta x is 0.5. How do I know it's 0.5? Well, you're going from 0 to 3. That's a distance of 3. They told us to chop it up into 6 equal pieces. 3 divided by 6, 0.5. So 0.5, 1, 1.52, 2.53. And I drew a quickie graph, but I laid down the nice numbers. When you plug in 0, you get -4. 0, -4. 1 gives me -3. 0, 0. 2, 0. Plug in 2, you get 0. Plug in 3, you get 5. Okay, so it's curving like that. As we know, a parabola is supposed to curve like that. Okay, they told me to pick the midpoints. So here are the 6 midpoints. Right, so 0.25, 0.75, 1.25, 1.75, 2.25, 2.75, right? So here's a picture. I'm estimating the integral bounded by the graph and the x-axis. It looks like it should be a negative, right? Because the true area here would be considered positive. The true area here would be considered negative. It looks like there's more negatives than positives, right? Okay, so when I go base times height, base times height, base times height, looks like there's going to be more negatives than positives, right? So I want the function value at all the midpoints. Okay, so M6, so what's this M6 stuff? M stands for midpoints. L would be left endpoint. R would be right endpoint. Okay, they told me to use midpoints. So all the bases are 0.5. So you would go base times height, base times height, base times, and again, the heights might be depth, D-E-P-T-H-S, meaning they're negative. So these are depths. Looks like these two are positive. Okay. Well, all the bases are 0.5, so you might as well just factor out the 0.5 and get the heights. The heights are the function values at the midpoints. So f of 0.25 plus f of 0.75 plus f of 1.25 plus f of 1.75 plus f of 2.25 plus f of 2.75. Okay, the heights at all of these. And again, a lot of them are negative. Okay, so I plug these into the function. The function is x squared minus 4. So it's going to be 0.25 squared minus 4. There it is. 0.75 squared minus 4. 1.25 squared minus 4. 1.75 squared minus 4. You just keep plugging into this. And then 2.25 squared minus 4. And then 2.75 squared minus 4. And you can see from the numbers, you don't get a positive until the last two. And that's kind of borne out by the picture, right? Looks like this one, this one, this one, this one are all going to be negative, and the last two are going to be positive. And that was just from my rough picture, but that seems to be borne out by the actual values that we get. Okay, negative, 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 positive, positive. Okay, grind it all out. Negative 3.0625. All right, so my guess for the true value might be negative 3. I don't know it really is negative 3. I'm thinking negative 3 just because it's a nice number nearby, so to speak. Okay. So the true value of the integral would be this true area minus this true area, which right now is just theoretical. We don't know how to get a handle on it exactly. We can just do this, chop into so many pieces and do base times height stuff. Okay. All right, that's that one. Next, I'm going to show you number 5, the other picture one. So again, please notice the notation, integral from 0 to 10 of f of x dx. Okay. Now, again, if I don't have the 0 and the 10, that was section 4.9. Those were indefinite integrals. Okay. So your answer is going to be an antiderivative plus c, just like the quiz. Blah, 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 plus c. When you have a number here, 0 to 10, you're talking about the true area, quote unquote, where this part is considered positive, then all of this stuff, which is negative, then all of this stuff, which is negative, and then everything under the curve bounded by the x-axis, which is positive. And offhand, just by eyeballing it, I don't even know if it's positive or negative for the final answer. But be that as it may. Okay, so from 0 to 10, this time we're counting by ones. Okay, the one that I did last time, number 6, you have to be careful because those went by ones, right? Each square was a half, right? That was 1 and that was 1. But for number 5, each square is 1. So we're going out to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is 10, and that's 0. So there's the picture involved. All right, so 0 to 10. That means the length is 10. 5 subintervals. So what's my delta x? 2, right? Going from 0 to 10, chop it into 5 equal pieces. 10 divided by 5 is 2. So the subintervals, smaller intervals, are going to be from 0 to 2, 2 to 4, 4 to 6, 6 to 8, 8 to 10, right? And then it tells us to use either right endpoint, left endpoint, or midpoints. Okay, I'm going to do them out of order. You know, the order doesn't matter, but I'll just show you what I got. Okay, so here are the subintervals: 0 to 2, 2 to 4, 4 to 6, 6 to 8, 8 to 10. Okay, we're going on the closed interval from 0 to 10. They said n equals 5. Chop it up into 5 pieces. So delta x is 2. So each subinterval has a length of 2. So 0 to 2, 2 to 4, 4 to 6, 6 to 8, 8 to 10. Now, let's take the interval from 0 to 2. Temporarily ignore the rest of it. If I'm going from 0 to 2, what's the left endpoint? 0. What's the right endpoint? 2. What's the midpoint? 1. Right? Fairly straightforward. Same thing for the next one. From 2 to 4. All right? You're going from 2 to 4. This is a sub-interval. Keep in mind, each sub-interval is an interval itself. Okay? I mean, if I just say the interval from 2 to 4, that's a legitimate interval. The reason why we say sub-interval was the original interval was from 0 to 10. And we chop it up into 5 smaller sub-intervals, but they're intervals in their own right. Okay, 2 to 4. That's the interval. What's the left endpoint? 2. What's the right endpoint? 4. What's the midpoint? 3. And just keep doing all the way through. So the left endpoints are 0, 2, 4, 6, 8. The right endpoints are 2, 4, 6, 8, 10. The midpoints are 1, 3, 5, 7, 9. So I'm computing L5, R5, and M5. Yeah, it's a little bit out of order, but you get the idea of these. Okay, so we're doing a bunch of base times height stuff. Remember, some of the heights are really depths. Oops, I lost this picture. The delta x is always 2. So the base is, when we do base times height, base times height, base times height, base times height, base times height. All the bases are the same, so you might as well factor them out. It's going to be 2. 2, 2, 2. These are the delta x's, the bases. Now the heights. So for L5, sorry, I can't show you the book and my numbers at the same time, but I'll talk about it, then I'll just show you what I ended up with. Okay, so the left endpoints, I want the height at 0, 2, 4, 6, and 8. Okay, so the height at the left endpoints. So the height at 0 is 3. At 2, it's -1. At 4, it's 0. At 6, it's -2. And then 8, looks like it's 2. Those are the 5 numbers that I just said. Okay. So this is the function value at 0, 2, 4, 6, and 8. The 5 left endpoints. Okay, grind it out. 4. R5. Take the heights at the 5 right endpoints. 2, 4, 6, 8, and 10. We already did 2, 4, 6, and 8, so we can just copy. So this one's a copy, that's a copy, that's a copy, that's a copy, and that's the only new one. But if you don't want to do that and you just want to go strictly by the book, literally, let's go ahead and do it. So the function value at the right endpoints, which are 2, 4, 6, 8, and 10. So function value at 2, -1. Function value at 4, 0. 6, -2. 8, 2. And 10, 4. Those are the numbers that I just said. Sorry, I can't show you both at the same time. -1, 0, -2, 2, 4. Okay, these two cancel out. -1 plus 4 is 3. 3 times 2 is 6. And M5, the midpoints. The heights, the function values at 1, 3, 5, 7, 9. Okay, so what are the heights? Some of them are negative at 1, 3, 5, 7, and 9. Okay, 1, 0. 3, -1. 5, 1, 2, 3, 4, 5, -1. 6, 7, 0. 7, 8, 9, 1, 2, 3. Okay, so the heights again were 0, -1, -1, 0, and 3. 0, -1, -1, 0, and 3. 2. Okay, so L5 is 4, R5 is 6, M5 is 2. They're all different, as you might expect, to be different. They don't have to be different, but most of the time you would say they'd be different. Okay, because we're estimating the true area, or signed area, I should say, SIGNED, signed area, bounded by the curve and the x-axis, because we're doing it in different techniques. So ultimately, all three of them came out positive. So they're trying to say there's actually more area above the curve than below, right? So that's positive. All of that's positive. This piece here would be negative. This piece here would be negative. Okay, and they're saying there's more net amount above than below. Okay. So that's that one. Okay, next one I was going to show you is, I should start marking some of this off. 7, where all they give me is a table. But nevertheless, that shouldn't be too bad. A table of values of an increasing function f is shown. Use the table to find lower and upper estimates of the integral from 10 to 30 of f of x dx. Okay, so all they give me is a table. Notice the notation, integral from 10 to 30. Okay, the signed area, S-I-G-N-E-D, signed area between 10 and 30. Okay, and you can see from the table, stuff that's below the x-axis, stuff that's above the x-axis. So all of these will be counted as positive. All of these are counted as negative. Okay, take a look at the table. Look at the x values. What's my delta x? 10, 14, 18, 22, 26, 30. So my delta x would be 4. Okay. And you have to be a little bit careful here. What's my n? It's not 6, it's actually 5. Okay, you can tell you have the length of the interval is 20, right? From 10 to 30 is 20. Each subinterval is a length of 4, so 20 divided by 4 is 5. Okay, even though you have 6 data points, there's 5 subintervals. The subintervals are 10 to 14, that's 1. 14 to 18, that's 2. 18 to 22, that's 3. 22 to 26, that's 4. And 26 to 30, that's 5. Right? Now, there are 5 left endpoints. Here they are, 10, 14, 18, 22, and 26. Right? Because the subintervals are from 10 to 14. What's the left endpoint? 10. The next subinterval is from 14 to 18. What's the left endpoint? 14. Same thing, 18 to 22. The left endpoint is 18. 22, 26. Left endpoint is 22. And finally, for the last subinterval, which goes from 26 to 30, the left endpoint is 26. So I'm never using the 30. Now, you can see from the table, it's an increasing function. So the lower number is always the left endpoint, right? Negative 12 is less than negative 6. Negative 6 is less than negative 2. Negative 2 is less than 1. 1 is less than 3. 3 is less than 8. Okay, so for the lower estimate, my delta x is 4. And my heights are negative 12, negative 6, negative 2, 1, and 3. So lower estimate, delta x is 4, negative 12, negative 6, negative 2, 1, and 3. Punch it in your machine, negative 64. Where's that negative 12, negative 6, negative 2, 1, and 3 coming from? The left endpoints, negative 12, negative 6, negative 2, 1, and 3. You say, what about the 8? I don't use the 8 because that's a right endpoint. It's not a left endpoint. Now, if I'm trying to find upper estimate, Since this is an increasing function, the upper estimate would always be the number to the right. Meaning between 10 and 14, which number should I pick, negative 12 or negative 6? Negative 6 is the larger number. Between 14 and 18, which is the larger number? Negative 2. Same thing here, 18 and 22, 1 is larger. 22 and 26, 3 is larger. Finally, from 26 to 30, 8 is larger. So I'm picking the 1, 2, 3, 4, 5 right endpoints for the upper estimate. So upper estimate, delta x 4 times the 4 right endpoints, negative 6, negative 2, 1, 3, 8. There we are. Negative 6, negative 2, 1, 3, 8. Add them all up, multiply by 4, 16. And by the way, you can tell this is probably not very accurate. I mean, I got one answer that's negative and the other answer that's positive. Okay, so clearly not an accurate reading, but that's the best we can do for now. Okay, so our lower estimate for the integral is negative 64. Our upper estimate is 16. Okay. See, we're also kind of sort of handicapped by not even seeing the graph. Right? We only have these 6 fixed points, but you know there could be a lot of stuff that goes on in between, right? Maybe at 12 it shoots way up or it shoots way down. We don't know from this data, so that's the best that we can do right now. Okay. All right, then 9 I did last time. Number 11. Use the midpoint rule. Okay, so integral from 0 to 2 of x over x plus 1 dx. Okay, this is right now just theoretical. We don't know how to do this exactly, but we will. And n equals 5. Okay, so what's my delta x? What's the length of the interval? 2. From 0 to 2. Chop it up into 5 pieces. So delta x is 2 divided by 5, 0.4. Here's the picture. 0 to 2, n is 5. So delta x is 2 divided by 5. That's a 5 there, sorry. Which is 0.4. So we go from 0 to 2. 0.4, 0.8, 1.2, 1.6, 2. Perfect. 1, 2, 3, 4, 5 subintervals. The subintervals are 0 to 0.4, 0.4 to 0.8, 0.8 to 1.2, 1.2 to 1.6, 1.6 to 2. That's 5 subintervals. And they told me to use the midpoint rule. So here are the midpoints. What's midway between 0 and 0.4? 0.2. What's halfway between 0.4 and 0.8? 0.6. Halfway between 0.8 and 1.2? 1. Halfway between 1.2 and 1.6? 1.4. Halfway between 1.6 and 2? 1.8. So I want the function values at these midpoints. Okay, I'm not even going to draw this graph. I don't want to. It's no fun. But it's going to be, you know, base times height, base times height, base times height, and so on. But all the bases are the same, so you might as well factor out that common base, which is 0.4. That's my delta x. Okay, so you always put the delta x in front, 0.4, and now you worry about the heights at the midpoints. F of 0.2. Caution, we're not adding up 0.2, 0.6, 1, 1.4, and 1.8. We're not adding those up. We're adding up the y coordinates that are associated with those values. In other words, the function values. F of 0.2 plus f of 0.6 plus f of 1 plus f of 1.4 plus f of 1.8. Okay, now, what is the function? X over x plus 1. So I plug in all these guys. So here we go, right? 0.2 over 1.2 plugging in here, right? The midpoints, 0.6. 0.6 over 1.6. 1 over 1 plus 1, which is 1/2. 1.4 over 1.4 plus 1, 2.4. Then f of 1.8, 1.8 over 1.8 plus 1, 2.8. Okay, punch all that in the calculator. I got 0.9071. There's the answer for that one. Okay, folks, that's pretty much about it for today. I still can save these for tomorrow, 33 and 34, and then 35 to 41 odd. I'll just show you what it's about. So I'll be done in a few minutes, and then if anybody wants to ask questions, you may. If not, then we're done for the day. But let me show you 33 and 34, what it's about. Okay, so they're asking you to estimate by interpreting in terms of areas. Okay, so they got the integral from 0 to 2, 0 to 5, 0 to 9, or whatever. Okay. Now, these we can get exactly because these are all straight lines. We know how to deal with areas involving straight lines. 34 we also can do, I claim, because they're saying that this is a semicircle. And we know how to find the area of a circle, right? Pi r squared. Okay. So we can find exact values for 34, and we'll be working on that tomorrow also. Okay, then what else is in this section? See, 35 to 41, 5.2. So interpret in terms of areas. So there's something about the problem where you can figure out the answers by drawing a picture. Okay. Actually, you can do 41 right now. If you can see it. Yeah, let's knock out 41, then I'm done. Integral from 1 to 1 of square root of 1 plus x to the 4th dx. So how much area is there if I start at 1 and I end up at 1? Question 41. There isn't any, so the answer is 0. Right? So the question 41, I'd give you that one. That's 0. Right? So that one's finished. All right, but the others I'll save for tomorrow. That's all the time I was going to do. So I was going to finish 5.2 tomorrow, start 5.3 Wednesday, and give you a quiz. But we still got plenty of time. We still have a couple of weeks after that to finish everything up. So time-wise, I think we're still okay. All right, so it looks like the shared screen did last the rest of the class period, so I'm glad for that. Okay, so let's see, any other questions? Upper and lower sums. So the upper sums are just upper and lower estimates. Okay, so for that one problem that I did, problem 7, right? Problem 7. Okay. It's an upper estimate of the true value and a lower estimate of the true values. It looks better if you draw the rectangles. Okay, so remember we were drawing the rectangles. Bother to do something quickly about that. Okay, I'll try it. I'm going to try to share the screen again, and I hope it works. Yeah. Okay. So if I have a picture like this, right? And let me just chop it up into 3 pieces. Okay, if I pick the left endpoint, that is clearly too small, so that would be an underestimate, a lower sum. Okay, if I pick the right endpoint, my rectangles would look like so. Okay, so if I add up the areas of those 3 bigger rectangles, that's clearly too big. I'm trying to estimate the area under the curve like so. Okay, so these 3 smaller ones, okay, maybe I'll write 1, 2, 3 like that. 1, 2, 3. That would be a lower sum, lower estimate. Okay, and then that one plus that one plus that one would be an upper estimate. Okay. All right, and yeah, that's pretty much about it, folks. So anybody else with a question? Otherwise, we're done for the day. All right, we'll continue with this tomorrow then, folks. Okay, have a good afternoon, and we'll see you all tomorrow. Okay, bye, everybody.